Scorpion Hexapod Robot. This terrifying robot looks like a real scorpion and was developed by 3 students from the University of Ghent in Belgium. They used the most modern technologies to create this robot. The modules for the legs and the tail, for example, were printed on a 3D printer. The frame of the construction consists of 2 plastic 6mm wide plates. Inside the frame there are pipes for the cables, while resistant special latches hold together the different parts of the construction. The robot can move in all directions, overcome obstacles, grab objects with its tweezers, and even attack using its tail like a real scorpion. To find the obstacles, the robot uses infrared sensors and a frontal camera. To achieve an even more prodigious resemblance, the tail of this mechanical animal leaves a red ink mark when attacking. It's not poisonous for humans, but will let you see the way the creature attacks. Nero. This small mechanical fish can carry out research work at a depth of 165 feet, but it's also a great tourist attraction thanks to its bright look, its LED lights, and its incredible and very real movements. Each of these fish has 2 motors and 4 infrared distance sensors, thanks to which the device can overcome any obstacle. This water robot can be controlled in first person using glasses and a controller. Spider Robot. This huge spider robot was designed using a 3D printer, and despite not being able to climb ceilings and walls like real arachnids, its appearance is quite real. The toy moves thanks to 26 different motors, 3 on each leg and 2 more located in the back of the device. This system allows the spider to move and perform movements with its stomach. The engines are not very powerful, but altogether can guarantee a movement similar to that of a real animal. The spider is controlled with the help of an application or a special joystick, which makes the job much easier. Also, the spider does not need to be programmed in any way. The bionic spider is simple to control and can run, lift its legs one by one, crouch down, and even dance. Robo-Bees. This tiny robot can be considered the smallest and lightest flying vehicle in the world. Not bigger than a stationary clip, it weighs 100 milligrams, that is to say 0.1 grams. The robot has 2 moving wings and is capable of maneuvering in the air. However, it's not completely autonomous and needs to be connected to a base with the help of a few transparent cables. In spite of this, the small device can be considered a true insect. This effect is achieved thanks to the frequency of the flutter, which is close to that of a real bee. And the small size is not the only advantage of this bionic animal. Among other things, the designers added the possibility of landing on the surface of water and swimming for a few seconds. Obviously, the flutter frequency, which reaches 120 times per second in the air, is significantly reduced. Underwater, the robot is able to move its wings with a frequency of 9 times per second. In the air and in the water, a monitoring system controls the robot with the help of several cameras. This system calculates the flight path and converts the calculations into commands for the robot. Flying Bionic Bird. Unlike other more common and popular drones which use a special propeller system for flight, this small device is capable of flying with the help of its own wings. When the robot's in the air, even other birds may think it's a real bird. This is possible thanks to the appearance of the device. The dark grey aerodynamic chassis has been decorated with a beak and a pair of eyes. The wings can also flap 18 times per second, and the tail is used to control the flight. In addition, the body of the bird robot is made of elastic synthetic foam, resistant to scratches, attacks by other animals, and possible hits during forced landings. The wings of the robot are made of carbon fiber, a durable but very light material, ideal for all kinds of maneuvers in the air. The total weight of the device is 9.2 grams, while a special and ultra-light battery weighs only 1.6 grams. A special decorative egg allows you to charge the bird. The drone is controlled with the help of a free mobile application, available for iOS and Android. There are 2 control modes according to the user experience, Simple and Expert. The control radius of the device is 330 feet, and a battery charge guarantees 6 minutes of work at maximum speed, or 7.5 minutes at normal speed, while a decorative egg allows between an hour and 75 minutes of charging. Plurobot. The company BioRob, which works in the creation of new generation bionic robots, has presented a robotic lizard, whose behavior resembles that of a salamander. To faithfully reproduce the particularities of the movement of these lizards, the developers used X-ray images. This allowed them to accurately recreate all the details of the animal. Like true lizards, which have great mobility, their mechanical analogues can also move through difficult terrain and even swim. A waterproof skin allows the device to remain for a long time in the water, which is why this bionic animal can be used for search and rescue. The construction of the robot allows controlling each active joint separately, whereas a model of neural networks responds for the control of the robot. The structure simulates the nervous system of some parts of the brain of a real salamander. This approach allows the robot to accurately copy the studied movements, in addition to performing complicated tasks which go beyond the possibilities of a real salamander. According to the developers, they hope to continue with their creations, and probably in the near future will show us a robotic dinosaur. Airacuda. The company Festo, famous in the world for its robotic animals, has presented their new son, the robot fish Airacuda. In addition to fins motors, which allows copying the exact movements of a real fish, the device has liquid muscles, a creation patented by the company itself. These muscles have elastic hoses made of rubber as well as aramid fiber. Using compressed air, the mechanical muscles move in the same way normal muscle tissues move, stretching or contracting as needed. 2 muscles are enough to begin the movement of the rear flap of the fish robot, while 2 other muscles are responsible for the control, allowing great maneuverability even in deep waters. Like a real fish, inside this robot there is a swimming bladder, a special cavity that allows regulating the compressed air and setting the fish in motion. To use this mechanical fish for 30 minutes, you need 400 liters of compressed air. Aqua Jelly. Here we have an autonomous artificial jellyfish with an electric propulsion system and an intelligent mechanical system which can adapt to any external changes. A transparent hemisphere and 8 tentacles with LED lights make up the bionic jellyfish. Inside we can find a central motor, 2 lithium-ion batteries, a navigation block and 2 servo motors to control movement. The robot's able to calculate the power supply, and when the battery's running out of power, the device automatically sends the information to the charging base, located on the surface, and swims to it on its own. To communicate on the surface, the mechanical jellyfish uses a radio band, and when being underwater, it uses a system of infrared lights, with a working distance of about 3 feet. That way, when receiving the signal from another robot in the vicinity, the jellyfish can perform an evasive maneuver. In addition to the environment sensors, the robot has internal sensors to control the energy level and pressure, thus calculating the immersion depth with high accuracy. Hewan. This robotic snake, developed by the Norwegian Institute of Science and Technology, has been specially created to work underwater. Its mission is to perform observation and repairing works of oil facilities, as well as recording videos underwater and investigating sunken ships. A cable is currently used to interact with the robot, but in future it will be able to swim autonomously and perform underwater research without an external signal. The elastic electronic construction of the underwater device allows its use in complicated places, which cannot be reached other than using other special equipment. That way, the bionic snake is a cheap and practical solution to perform technical tasks of low difficulty. This robot can help perform inspections, illuminate dark areas, clean underwater constructions, and screw nuts and valves. RoboCrab. The creators of this unusual robot were inspired by the Ziphosaura, one of the oldest animal species on planet Earth. The device moves using a set of small legs, pushing itself away on the surface, and is able to return to its initial position using its movable tail, in case the robot turned on its belly. Like the animal prototype, this mechanical crab is not afraid of water and can move easily in shallow waters.